Hello everyone. Today I am starting the lecture series of probability, and this series will be beneficial for all the CSC 4th semester students, IT 4th semester students also, and if there is any CSPS students, so that these videos will be beneficial for them. So let's start today's topic. So first of all, let's discuss the syllabus of probability which are included in JIS group syllabus. So this is the syllabus of probability, basic probability. First is discrete and continuous random variable, probability mass function, probability density function, cumulative distribution function, and so on, and also expectation, moment, and moment generating function. Also there are some distributions. You have 4 or 5 distributions: binomial, Poisson, uniform, exponential, and normal distributions. And in my lecture series I will complete full syllabus. Okay, but before starting the discrete and continuous random variable, we have to know, or we have to understand some basic definitions of probability. And in probability there are some mathematical words. We have to know what is the meaning of that mathematical words. For example, if I say that you have two event, so obviously you have to know what is event. Suppose I am saying that mutually exclusive event. Okay, so obviously you have to know what is mutually exclusive event, what is exhaustive event, and so on. Okay, so in this lecture, in this lecture number 1, I will discuss total 15 mathematical words which are included in probability. Okay, then in my next lecture I will discuss the basic concept of probability, and in lecture number 3 I'll discuss your syllabus, the first topic, random variable, discrete and continuous random variable. Okay, again I am repeating. First lecture I will discuss some mathematical words, their definition, their meaning of the mathematical words. In second lecture I will discuss the basic concept of probability with some example. And in third lecture I will start your syllabus, discrete and continuous random variable. Okay, so let's start. First is random experiment. What is random experiment? Actually, probability, this is totally depending on experiment. Okay, so random experiment means this is an experiment, or you can say that this is an observation which may be repeated a large number of times. Okay, and you will get some outcome depending on some identical conditions. Okay, and the possible outcomes, you can describe the possible outcomes as they are predictable, or sometimes they are unpredictable. Okay, so let's me write the definition of random experiment. So an experiment or observations which may be repeated a large number of times. Okay, so an experiment or observations which may be repeated a large number of times under some identical conditions. Under very nearly identical conditions. Okay, and the possible outcomes possible outcomes are unpredictable or predictable. Clear? This is the definition of random experiment. So an experiment or observation which may be repeated a large number of times under very nearly identical conditions, and the possible outcomes are unpredictable or predictable. Clear? For example, a random experiment. So throwing a coin or throwing a dice, everything are random experiment. Now, second definition is sample point or event point. When the random experiment happen, so obviously you will get some outcome. Yes or no? Obviously you will get some outcome. That outcomes are called the sample points, or it is also called event points. For example, if I throw a coin, so what will be the outcome? Either that will be H or that will be T. So H is a sample point, T is a sample point. If you throw a dice, so obviously what will be the outcome? Either that will be 1, 2, 3, 4, 5, 6, etc. 1 is a sample point, 2 is a sample point, 3 is a sample point, 4 is a sample point, and so on. Okay, so what is sample point? Sample point is the outcome of a random experiment. Clear? Sample point is a outcome. So you can write the definition: the outcomes of a random experiment. Is called, or outcomes are called, sample points, or it is called event points, but most popular name is sample point. Clear? And you can write this example. Suppose you are throwing 2 coins. Okay, you are throwing 2 coins. So what will be the sample points? First sample point will be HH, HT, TH, and TT. So you have 4 sample points. Clear? Now come to the next topic, that is sample space or event space. What is sample space or event space? First step is we have to do the random experiment. Okay, so first one is random experiment. Now when you are experimenting, so obviously there will be some outcomes. So these outcomes are called sample point. Okay, now what is sample space? Sample space means the set containing the sample point. I am repeating, the set of all sample point is called sample space. Okay, the set of all sample point, okay, is called sample space. Okay, now let me tell you one thing. Here I have mentioned a word, that the set of all sample points. What is the definition of set? What is the definition of set? Set means collection of distinct well-defined elements. Yes or no? Distinct well-defined elements. So obviously sample space, this is a set. So obviously if sample space is a set, so the elements in a sample space must be distinct. Yes or no? Suppose you are throwing a dice, and the outcomes are, let's say 1, 1, 3, 5, 2, 6, 4, 5, 6, 3, etc. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have thrown a dice 10 times, and these are the outcomes in my experiment. Okay, so all these outcomes all these outcomes are sample point. But when I am forming a sample space, let's say we denote a sample space by S. So what will be the elements in sample space? Sample space, this is a set. So obviously it will contain distinct elements. So what will be the elements in sample space? 1, we have 2, 1. So we have to take only 1. 2. Next we have this one, 3, 3. So we have to take only 1, 3. Okay. This is 4. This is 5. This is 5. So we have to take only 1, 5. And the last one is we have 2, 6 outcomes. So 6. This is your sample space. Clear? So sample space is the set of all sample points. Since sample space is a set, so obviously it will contain distinct sample points. Clear? Okay. So if I tell you that you have to throw 2 coins, so what will be the sample space? S is equals to, sample space will be HH, HT, TH and TT. Clear? This is your sample space when you are throwing 2 coins. Okay. So first we have learned, let's revise it. First we have learned random experiment. Random experiment. Okay. Second, the outcomes of the experiment. Outcome means sample point. Clear? Now collection of the sample point form a set, and that set is called sample space. Okay, sample space. So sample space is a set. In class 11 or 12, when you have learned the set theory, so you know that for every set there exists a subset. Yes or no? For every set there exists a subset. So obviously if sample space is a set, so obviously there must exist a subset of this sample space. And here is our next topic, that is event. What is event? Event is the subset of a sample space. Okay. So you can write the definition that any subset of a sample space, let's say capital S, any subset of a sample space capital S and sample space of a random experiment. Okay, is called an event. Okay, so event is a subset of a sample space. Clear? So let's form an example. Let's form an example. Suppose we have thrown a dice. Okay, and what will be the sample space? S is equals to, obviously there will be 6 outcomes. So 1, 2, 3, 4, 5 and 6. Okay. Now I have told you that form an event where the outcomes are even numbers. Okay, you have to form an event where the outcomes are even number. Okay, so let's say the event is capital A. Capital A is the collection of the outcomes which are even number. So in this sample space S, which are the even numbers? 2, 4 and 6. So in event, what will be the elements? 2, 4 and 6. So obviously the set capital A, this is the subset of S. Yes or no? So A is subset of S, and we call A, this is event, and S, this is our sample space. Clear? Similarly, if I tell you that collection of odd outcomes, so let's say this is B, so B is equals to 1 3 5. Obviously again this is subset of S, and here B is the event and S is sample space. Clear? Okay, now come to the next topic. When we are learning the subset, so obviously you have learned that every set is a subset of itself. Yes or no? Every set is a subset of itself, and also you have learned that null set phi is a subset of every set. Yes or no? And these two subsets are called improper subsets. Okay, this is the topic of class 11 or 12. I am repeating, every set is a subset of itself. Okay, if A is a set, or let's say X, if X is a set, so X is a subset of itself. And null set phi, this is subset of every set. You know these two results. So same concept, we can apply the same concept for event, because event is also a subset. So our next topic is certain event. So what is certain event? Certain event means, suppose you have an event, okay, or you have an sample space. Let's say capital S. Capital S is a sample space, and I have told you that every set is a subset of itself. So obviously we can say that S, this is subset of S. Okay, every subset is a subset of itself. So here S, this S is subset and this S is set, and in probability subset is called event and the set is called sample space. So this is our event and this is our sample space, and this type of event is called certain event. Clear? This type of event is called certain event. Okay, so what will be the definition? That we know that every set is a subset of itself, so the sample space is a subset of itself. Okay, so you can write that since every set is a subset of itself, so the sample space is a subset of itself. Okay, so obviously this is an event, this is an event. Okay, and this event is called a certain event. Clear? So this is the certain event. Now come to the next topic for null set. Every null set is a subset of the set. So this is the next topic, impossible event. What is impossible event? Impossible event means an event that contains no sample point. Okay, an event that contains no sample points. Okay, and you know that obviously this is denoted by phi, and you know the set phi is a subset of every set, so phi is subset of S, and here phi is our event and S is our sample space. Okay, and this event, this is called impossible event. Impossible event. Clear? Okay, now come to the next topic. Next topic is, this is number 7, complementary event. Complement means opposite. Okay, complement means opposite. So let's understand using an example. Suppose we have two coin. Okay, we have two coin, and obviously what will be the sample space for the two coins? HH, HT, TH and TT. Okay, let's say I am making an event, let's say capital A. Capital A equals to, let's say the event is TH and HT. Now question is, what will be the A bar? Complement event is denoted by A bar. This is called complement event of A. So complement means opposite, that means S minus A. So in S set these are the elements, and in A set these are the elements. So what will be the A bar? So it will contain HH and TT. Okay, similarly if S is equals to 1 2 3 4 5 6, and let's say I am making an event capital A, collection of the even outcomes, so 2 4 6. So what will be A bar? The remaining elements, that means 1 3 and 5. Okay, this is the concept of complementary event. Obviously this is very simple. Okay, so next come to the next topic, simultaneous occurrence of two events. Simultaneous occurrence of two events, that means two events are occurring together. Okay, suppose we have two events, let's say A1 and A2. Okay, and if they are occurring together, that means this is the concept of intersection, na? If you think using the concept of set theory, so simultaneous occurrence of two events, that means it is occurring together. Okay, that means the intersection point. So simultaneous of occurrence of two events means A1 intersection A2. Okay, so A1 event and A2 event both are occurring together. Okay, and this event is denoted by A1 intersection A2. Sometimes in textbook, some textbook you will get the denotation as A1 into A2. Okay, both are same, A1 intersection A2 or A1 into A2, like in this way. Okay, not actually into. So some textbook you will get this denotation. So this is also mean simultaneous occurrence of two events. Okay, for example, suppose, let's understand using an example. Let's say this is S. I am taking the same example, die, throwing a die. S is equals to 1 2 3 4 5 6. Okay, let's say A1 is let's say even phase. Okay, A1 is even phase. Even phase means the even outcomes, so 2 4 and 6. Okay, and let's say making another event here the phase are multiple of 3, multiple of 3. So what will be the outcomes? Multiple of 3, so obviously two outcomes, 3 and 6. Okay, now question is, you have to form an event simultaneous occurrence of two events, that means A1 intersection A2. So what is the intersection point? Obviously there is only one element, that is 6. Okay, so A1 intersection A2, that will be 6. Clear? This is the concept of simultaneous occurrence of two events. Okay, and almost same concept but opposite. at least one of two events. At least one of two events means simultaneous occurrence of two events is intersection, and at least one of two events, that is union. Okay, suppose you have two events A1 and A2. If I say you that at least one of two, that means you have to form A1 intersection A2. Sorry, A1 union A2, or in some textbook it is also denoted by A1 plus A2. Okay, so you can use any one of the two symbols, A1 union A2 or A1 plus A2. Okay, for example, suppose I am taking the same example. Suppose A1 equals to the even phase. Okay, so 2, 4 and 6, and A2 equals to multiple of 3. So this is equals to, this will be 3 and 6. Okay, and what was the sample space? S is equals to 1, 2, 3, 4, 5, 6. Okay, now at least one of two events, that means A1 union A2, or you can write A1 plus A2. So this is equals to union of the two sets. So this will be 2, 3, 4 and 6. This is the set or event at least one of two events. Okay, now come to the next topic. Next topic is mutually exclusive event. This is very important. Mutually exclusive event, this is very important. What do you mean by mutually exclusive event? Suppose we have two events. First one is A1 and second one is A2. Mutually exclusive means there is no common sample point between the two events. There is no common sample point between the two events. That means you can say that A1 intersection A2, this is equals to 5. Yes or no? There is no common element between the two events. So A1 intersection A2, this is equals to 5. So what is mutually exclusive event? Two events A1 and A2 having no common sample points is called mutually exclusive events. Okay. For example, let's say A1 equals to HH and HT. Okay, and A2 equals to HT and TH. So obviously there is no common element or no common sample point. So A1 intersection A2, this is equals to 5. Okay, so you can say that A1 and A2 are mutually exclusive. Mutually exclusive. Clear? Similarly, suppose A1 equals to the even phase, that means 2, 4, 6, and A2 equals to the odd phase 1, 3, 5. So obviously A1 intersection A2 equals to 5. Clear? Achha, mutually exclusive, this is also known as disjoint event. Mutually exclusive, this is also known as disjoint event. Okay, now next topic, number 11, pairwise disjoint event. Pairwise disjoint event means suppose we have more than two events, A1, A2, A3, A4 and so on. I am taking only 4 events. Okay, pairwise disjoint event means each pair will be disjoint. Okay, that means A1 intersection A2, that will be 5. A1 intersection A3, that will be 5. A1 intersection A4, that will be 5. Similarly, A2 intersection A3 is equals to 5. A2 intersection A4, this is equals to 5. And the last one, A3 intersection A4, this is equals to 5. This type of events are called pairwise disjoint event. Okay, each pair of the events will be disjoint. Okay, or you can say pairwise exclusive event. Clear? So this type of events are called pairwise disjoint event. Now come to the next topic, exhaustive event. This is number 12, exhaustive event. What is exhaustive event? This is also very, very important. Mutually exclusive event and exhaustive event. These two terms are very, very important. So what is exhaustive event? Suppose we have A1, A2, A3, A4, 4 events. There may be any infinite or finite number of events. Okay, I am taking only for an example, I am taking only 4 events. Okay, A1, A2, A3, A4. Now, if the union of the events form the total sample space, let's say S is the sample space. S is the sample space and A1, A2, A3, A4, these are the events. Okay, if the union of the events, that means A1 union A2 union A3 union A4, if the union of the events form the total sample space S, then the events are called exhaustive event. Okay, if the union of the events form the total sample space, then the events are called exhaustive event. Suppose we have infinite number of events, A1 union A2 union A3 union dot dot dot, and this is equals to S. Then these events are called exhaustive event. Clear? Okay, for example, suppose A1 equals to, let's say, HH, A2 equals to, let's say, TT, A3 equals to, let's say, HT and TH. Okay, so if what will be the union, A1 union A2 union A3, and this is equals to HH TT HT and TH, and this is nothing but our total sample space S. So obviously these 3 events, this is called exhaustive events. Okay, now number 13, that is simple event. What is simple event? Simple event means an event which is containing only one element. Okay, simple event means an event containing exactly one outcome or one sample point. Okay, let's say A1 equals to singleton element 2, A2 equals to 5, etc. Okay, an event containing exactly one sample point is called simple event. Next topic is composite event. Composite event means, suppose we have an event, and if we can decompose the event into some 2 or more simple events, then the event will be called composite event. Okay, suppose we have an event, any event, let's say capital A, and if we can break this event capital A into some events, let's say A1 A2 A3, and each event are simple event, here A1 A2 A3, each events are simple event, then the event A, that will be called composite event. Clear? So if we can break an event into some simple events, then we can say that the event is composite event. Okay, next one is very very important, number 15, and this is the last topic of today's lecture: equally likely sample point. This is very very important, and there is huge application of equally likely sample point in probability. Okay, mutually exclusive, impossible event, exhaustive event, equally likely sample points, all these topics are huge application in probability. So what is equally likely sample point? Equally likely sample point means, suppose we have two events, a1 and a2. Okay, we have two events, a1 and a2. Event means obviously it is containing some sample points. And equally likely, what do you mean by equally and what do you mean by likely? Equally likely means here the elements or the sample points in each event may not be equal. I am repeating, the sample points in each event may not be equal, but the number of sample points will be equal. Suppose in A1, let's understand using an example. Let's say S is equals to 1, 2, 3, 4, 5, 6. Obviously, this is I have thrown a die, and these are the outcomes 1, 2, 3, 4, 5, and 6. And S is the sample space. Let's say A1 is the event collection of event faces. So 2, 4, 6. And A2 is the collection of odd faces. So 1, 3, 5. So obviously A1 and A2, the sample points are not same. Okay, but the number of points or number of sample points in each event are equal. In this case, a cardinality of A1, this is equals to 3, and cardinality of A2, this is equals to again 3. So number of sample points are equal, but the elements are not same. Elements may be same, may not be same. This type of events are called equally likely events. Okay, or you can say equally likely sample points, and there is a huge application of this equally likely concept. Okay, so this is our main topics in this video. In next lecture we will learn the classical definition of probability. Okay, I think this video will be very beneficial, and obviously this is basic concept of probability. Okay, so if already you know the all the concepts, so obviously you can make you can increase the speed of this video. Okay, but must watch this video, of must be this is beneficial for you. Okay, thank you so much.